Hi everyone, good afternoon. Do I am audible? Could anyone please respond?
Yeah, audible. You're audible.
Madam,
Yes, ma'am.
I'm audible.
Yeah, thank you for your response. So today we are here to have a national level webinar on the electronics department, which we are going to discuss on the major and the hot topic in the market, current trending market, which is on VLSI. Yeah, yes. Please just sorry for my inconvenience. There was some network issue from my end. Okay. Today we are here to discuss on the national webinar, which are discussing on the VLSI, and the trending topic is FPGA design, which we are all aware of, like field programmable gate array. So which is an trending subject and also trending topic, which is currently discussing in the market and a very demand in the like industrial areas where you are currently deployed in the project itself. So coming to our company, so Skill Desire is an edtech platform. We are here to provide the internships and job-oriented courses to the students, so that while pursuing the career in the skill design, you're having to have a very good placements in your chosen subject and in your chosen departments. And discussing on the regarding today's topic, here we are having a very great expert, Mr. Manohar sir, who had a very great experience around 3 to 4 years of experience in the VLSI design. And also he used to work as an FPGA design engineer. And he's an currently working expert. So you can have a very good interaction with the sir and you can solve all your queries regarding that. Manohar sir, could you please continue the session?
Yeah, yes, Nitya. Hi everyone. So, how are you all? Fine, right? So, myself is Manohar. Currently, I have experience, 5 years of experience in VLSI domain. Currently, I am working with the Capgemini Private Limited as a professional design engineer here. Okay. So, anyway, glad to meet you all the guys. It is very happy situation for me. So to give session on FPGA because FPGA is a very trending technology, not a trending, it's an evergreen technology to the future students, okay, who are ready to join in the FPGA team. Okay, it's very great thing because as a ECE student, you should be proud. I'm a ECE student. I'm doing the job in the FPGA. Correct. So FPGA and ASIC both are similar only, but the thing is, FPGA is having some different tools and ASIC is having different tools. Both are similar only, but tools are different. But the thing is, FPGA is we have FPGA is providing only two vendors. It's like Xilinx, AMD, and Intel. Okay, Xilinx, AMD both are same. Okay, so these are the two vendors giving the multiple FPGAs. Okay, so this is the introduction of just brief introduction. Okay, if you want to know more about details, you can go to the Xilinx website and Intel website, then you can find anything. But as from my side, I can give you more information and also guide how to approach the FPGA programmings. Okay, I will give you from my side. Okay, I will share my screen. Please let me know if my screen is visible or not. It's visible, right?
Yes, sir.
Yes. Thank you so much. Basically, what's an FPGA? FPGA is nothing but a field programmable gate array. Okay. Field is, it's like a chip. Okay. And programmable, like as we know already, it's like a C, C++. These are the programming languages, right? But okay. And gates. Gates is nothing. Gate array means, what is a gate? Gate is nothing but a what we are studied in the digital design, right? That is called as a gate. Okay, array. So we need to implement all the gates. How we need to implement in the field. Okay, these are the different scenarios we need to learn. So that's why this is called as a field programmable gate array. Programmable languages we're using here. Hello.
Hello. Hello. Hey.
Hello. Excuse me. Okay. So this is called as a field programmable gate array. Fine, right? So what is the background of FPGA? First we need to go to the history, then back to the FPGA. Okay, fine. First we need to learn digital design. You want to do work on the field FPGA. So first you need to know the digital design. Okay. How it is the digital design? See, when you see the picture, what are the things appears here? Okay, see, first it is diode, correct? We learned already. We studied diode. You wrote the exam also in semesters. Diode, transistors, MOSFETs, bipolar. Initial stage. This is the first step is for the FPGA is diodes. Okay, N and P, intrinsic semiconductor, correct? Extrinsic semiconductor. You learned all these things. Okay. Beyond this, after this, we'll go to the technology. Okay. CMOS technology. It's a parallel connection and series connection. So many are there. You studied in your semesters. Okay. After that, logic gates are came. What is the logic gates? Logic gates, when you look at the logic gates, these are having 4 combinations. Like that means 2 input bits. Coming to the diode, how many bits are there? Only one power supply is there. You need to monitor from the power supply. If you give 1, it will be enabled. If it is 0, it will be off, right? The diode acts like a switch. So like that, when you coming to the gates will be having different functionalities. 1, 2, 3, 4, right? 0, 0, 0, 1, 1, 0, 1, 1. Correct? So the logic gates into came here, the logic gates. After that, what will happen? Circuits we need to see. With the logic gate, we will give applications, no, right? So only one logic gate it is not doing anything. Multiple logic gates we need. Then that's why we came into combinational gates and sequential gates. What are the combinational gates and sequential gates? Combinational gates are whatever the inputs, right? We have, outputs will be appear. What are the sequentials? The sequential gate is nothing but it's a clock. It depends upon the clock. Correct. In the combinational clock, there is no clock. I think everybody knows that because you are running the students, right? You are studying the all the digital systems, transistors, diodes, everything, right? So I'm just giving review here. After this combinational sequential, what will happen? Goes to beyond more. We need to see more combinational circuits, more sequential circuits, flip-flops, registers, counters, okay, latches, so many are there. Correct. That we need to implement in the FPGA. Before that, what will happen? Before the FPGA, what will happen? Microcontroller and microprocessor is there. Correct. Microcontroller, microprocessor. After the microcontroller and microprocessor, what will happen? We have seen some PLDs. Programmable logic devices. Okay, what is the programmable logic devices? The programmable logic devices having the two types of PLDs again, user PLDs and standard PLDs. So we have different scenario, all these things. Okay. After the PLD, what we have? FPGA. But PLD, we have designed already simple PLDs and complex PLDs, SPLDs and CPLDs. Earlier, CPLDs is having the programming. Okay. Everybody is doing that. Earlier in 90s. In the CPLDs, the programming is running. After the CPLDs only, they found FPGA, field programmable gate array. Correct. So we'll see that the tree also we can see how it is. See, this is a device. This is a system. Correct, right? Device is there. Circuits, so many circuits are there. Gates, modules, and system. This is the abstraction levels from device to system specification. You have a system specification, you need to design. They give like a, for example, it's like a ALU, arithmetic logical unit. In arithmetic logical unit, you have so many functionalities are there: adder, subtractor, multiplier, division. Okay, these are all the functions, right? We need to implement it. Then how? We need to implement. Adder means you need to take the adder. Subtractor means you need to take the subtractor. You know it, right? Half adder, full adder, subtractor, full subtractor, half subtractor. Correct, na? So these are all the basic things. When you are implementing high-level system specification, these are all the basic things you need to learn. You need to know. Then only you can design any system specification. How the gates will be act as, how the gates will be act when you implemented this system. You implemented some Verilog programming, right? It's a programming. How it will be act. How the hardware it will take as your components, like gates. Correct, right? So you need to think high-level manner only. But the thing is, you need to implement the codings in a Verilog or VHDL, right? That should be, we can see when you write a Verilog code for the AND gate, that you can see in the field programmable gate array. When you check, when you write a programming code in the Vivado, right? There you can write an AND code. For suppose C is equal to A and B, then the AND gate will be appear in the Vivado tool when you see in the schematic. So it will be different scenario. But the thing is, I'm telling you, it's a very specifically hardware specific. The programming language is a hardware specific. But C language, it is not a hardware specific. It's a system software. That's it. If you write a C language code, you cannot see in the hardware. You cannot see. But the Verilog code, you can write it. The hardware, whatever it is, whatever you write the code, the hardware you should be definitely you can see. We have some scenarios to see that. Okay. So we have discussed it. So this is the history. I'm telling you, everything is history only. PLDs, simple programmable logic devices, and HDPLDs. In the HDPLDs, complex C is there. Complex programmable CPLDs. These are called as CPLDs. And after that, field programmable logic devices, FPGAs are there. Okay. So earlier we have these technologies actually. PLA, PAL. What is a PLA? Programmable logic array. What is a PAL? Programmable array logic. What is the difference between them? In the PLA, right? In this PLA, and or are programmable. AND gate and OR gate, both are programmable. So both are programming means it will take more time, more consuming power. But coming to the PAL, what will happen here? Here, only OR is for fixed and is programmable. So what will happen? The less programming, correct? Less programming, less power consumption. Here, the consumption is more. So that's why we are came into the FPGAs, because these are all every technique is having some drawbacks. From the drawbacks only we are founding something new. Correct. Somebody asked, why can't we use SCADA? SCADA is not a much that programming language. This is a SCADA is depends upon the PLA, I think, programming language interface. Correct? I'm not much aware of that SCADA, okay, but I'm most aware of the FPGA. SCADA is a programming language interface. Correct? Yes. So, but SCADA is not that much efficient to implement more applications. Okay, the SCADA does not depends upon the Verilog. It will depends upon C language also. Just go through the SCADA programming analysis. It's a programming language interface, but it is not a programming language interface. It is a specifically hardware specification, hardware language. That's why Verilog is, what is the meaning of Verilog? Verify logic. Okay, so just see what is the architecture before the FPGA. It's a embedded. It is a embedded system design. What is the meaning of embedded system design? Meaning of an embedded system design, right? Whatever the different components you are combined in a one board, that is called as embedded. Okay. So here I am using CPU, central processing unit. There is no FPGA here. Earlier this is what the board to use everything. CPU, what it will do, central processing unit, arithmetic logic operations it will do. Correct? Generally we know, right? Okay. Yes, of course, definitely. Combination of software and hardware is known as a embedded. Yes, this is also embedded system only. Different components we have, different components having different softwares. Definition is not a main point here. Understanding more important. These are all the history. No one is using now. This one. Earlier this was using. Having some drawbacks. More time, it will take more time. More complexity is there. We need to take FPGAs will be very easy, right? So that's why these are the all backends. That's why we are coming into FPGAs. Okay. So the CPU is like we can write the program, sequence of instructions are there. We have some instructions to implement the CPU, right? Coming to the FPGA, right? It is a very special purpose. Whatever the hardware you want, you can write it. You can write the code, you can get that hardware. If you want to implement ALU, you can write a ALU code and you will get the board. It is easy. If you want to design some LEDs, you want to blink some LEDs in your home, you can write the Verilog code for that. You can implement it. The same hardware you can get it. That's it. Nothing more. You don't want to, nothing. Then you can get that board also. It is easy. When you know the programming of Verilog, how to implement one of the structure, then you will get it by using the Verilog programming. So these are all the history. Okay. Coming to FPGAs, right? Field Programmable Gate Array. Here we have two FPGAs. This is Xilinx Vertex. This is Intel Stratix 10. How many FPGAs are there? You know, every vendor for the Vertex, at least he will release minimum 50 to 100 FPGAs. Minimum 50 to 100 FPGAs. Then what it means? Every FPGA is having the different types of functionalities. Every FPGA based upon they decided, one is automobile industries and another one is military, another one is defense. Okay, these are the different types based upon the application. You need to take that FPGA. Some of the FPGAs is radio frequency based FPGAs. Okay. So different types of FPGAs are there. So coming to the Xilinx, okay, we have so many FPGAs are there, Artex, Kintex. These are all 7 series FPGAs. Now we are more than 7 series already. But still, 7 series FPGAs are more efficient. Now also we are using in applications. Example, Chandrayaan. Just think about Chandrayaan. BrahMos missile. We have listened, right? All these works with the FPGAs only. Okay, coming to the Intel. Intel is a very big product-based company. Those are giving so many products, FPGA products. Intel, Stratix 10, Cyclone 5, Cyclone 4, Cyclone 6, Max 10, Azilix. These are the different names. In the Xilinx, Spartan 6 is there, Spartan 5, Spartan 4, Spartan 3, Vertex, Kintex, Jink Ultra Scale. Now we are Jink Ultra Scale, the advanced FPGA it is. In the Jink Ultra Scale, so many are there. So many. Okay, see, just see how it will be. All the integrated chip products. These are all the integrated chip products. Central processing unit, DSP, digital signal processing, controllers, memory chips. What is the memory chips? RAM, ROM, EEPROM, analog, mobile communication is analog, audio or video processing, programmable, PLA, FPGA, embedded systems. These are all, see, all the examples we have, but we don't know. The police people are talking about the walkie-talkie phones, right? Correct. These are the mobile communication talkies. Every military people also talking with those, right? There we are using small FPGA, very small FPGA to the communication, mobile communication. Earlier we are using microcontrollers, but now we are using small FPGAs because FPGAs are very efficient. The result will be very clear when you are using FPGAs. See, when you are writing the code here, you have written some code. I told you, right? Whatever the code you want to write here, you can see the structure here. You can see the structure here. Here I written the multiplier code. Okay, I have seen some structure here. You want to get this only multiplier code board, you will get it from electronic shop. How? You will get the components and you can assemble it in one board. Take one of your breadboard. There you can see the structure, how many transistors are there, how many resistors it required, what is the power supply it needed. Go and take that components and you can put one breadboard. There you can keep everything. 10K resistor is required, 10K resistor it is required, and voltage supply you need to give. Okay, you can assemble it and you can do multiplier. Then it will be appear. So it is possible, but you write a C language code, you will not get hardware. No. C language is not a hardware descriptional language. Only Verilog or VHDL and system Verilog, UVM. What are all these? Verilog is a verify logic. What is a VHDL meaning? Very high speed integrated logic hardware descriptional language. VHDL. System Verilog. And UVM, universal verification methodologies. UVM is advanced. When you write your code, that is efficient or not, that will be decided by UVM. That much of power UVM have to verify your Verilog code. Who will do that? Verification team will do that. Then who will be write the Verilog code? Design team, design and development team. So 3 types of implementations are there here. One is front-end design, another one is back-end design, another one is verification and testing team. Front end means design and development. If you are a RTL designer, you need to write a Verilog code to them and develop the code. And coming to the backend, what will happen in the backend? Backend means when you write the Verilog code, right? After the Verilog code, you need to see how the how the components will be placed in the board. If any having issues placing the board, that will be verified by backend team. That is called as a PD, physical design engineer. Okay, coming to the next, testing and verification. First, they will do verification. After that, it will be going to the testing. What is the verification? Verification, you need to check whether the code is, even if the code is implemented also, they are verifying how much efficient it will be, how many cycles it will be works. Okay, like that they have decided 3 teams: front end team, back end team, and verification and testing team. What is the testing?
Hello, sir.
Yes.
Could you please try to solve one of my query?
Yes. Yes, tell me. What's your name?
Sir, I'm Nitya, sir.
Yes, Nitya.
So what are the designations we are going to get for if we learn, like what are the like designations we are getting into this team? Like if you learn FPGA, what are the, like, some of the roles? How we are going to get the roles?
Yes,
like,
yes. Yeah. Yes, Nitya. So basically, if you are learn FPGA, right?
yes.
So definitely will be the front-end designer only. RTL design engineer you will get.
Okay.
Purely it is a front-end design. Okay.
Okay.
This is not a physical design engineer, and maybe it is a verification also. We can verify the logics by using verification in the FPGA also. It is
So
possible.
there is one verification engineer. There is also some one department, right?
Yes.
So for testing, there is again there are so many engineers are involving just in chip making for this, like
Yes, but
verification engineer, testing, and
yes,
physical design.
yes, correct. So because if you are involved in one project, that's definitely the project, it will take 1 to 2 years, for example. Okay, everybody is involved in that. The major role is the front-end developers only, because front-end developers are very less. Basically, if you learned very much, you will be the design and developer, because coding you need to develop, then only backend team will come. Otherwise, what they will do? Backend team, nothing, right? So front-end team is the first basic is the front-end team only. After that only the backend team come. After that only verification team come. That's why the front-end is, you can more focus on front-end. You will get the job easily, because front-end teams are very less.
Okay.
Yes. So that's why I'm telling you Verilog code is the very basic one. If you want to do the job in Verilog till 5 years, after you want to see in the backend job also, you can try it. You will get it.
Okay, sir. Thank you for solving my query.
Yes, Nitya. So that's why I'm telling you, this is the basic, right? So the basic thing is Verilog. You learn digital design very thoroughly, very confident on that. Okay. Digital design. If you clear, the interviewer ask you digital design questions, you cleared every question to answer, you will get a job without asking any other questions or Verilog or FPGA or anything. Are you ready for that? That's why some profiles are there. Some companies, they called you not FPGA RTL design engineer. They called you as a digital design engineer. Okay. So many fabrication companies are there. They called you, still now, they called you only digital design engineer, not a FPGA engineer, not a ASIC engineer. Texas Instruments, the big fabrication company, broad-based company. Now they are called you digital design engineer, senior digital design engineer. Okay. So that's what I'm telling you. If you learn more digitals, then you don't know how it will be when you enter into the digital design job, or FPGA RTL job. Definitely you will be very happy. Okay. So I'm telling you, the FPGA is the future for AC student. It is evergreen. It is not a coming and go like this. No, it is not like that, because R&D is more, because everybody is using mobiles, right? Everybody is using in every home. Now, how many mobiles are there? 4 people are there in home. Definitely they have 6 mobiles, not 2, not 4. Definitely they have 6 mobiles, correct? How many electronics are there? Who will develop the electronics then? You only. The EC student only develop the electronics. No one kills all the problems. CSE people can't do this. EEE people, mechanical, civil, not eligible also for that, because they don't know digital design, right? You only know more. So 90%, you are trying the job in a core, FPGA or ASIC, whatever it is. Both are same only, but tools are different. Okay, definitely you will get it.
Excuse me, sir.
Okay. Yes, yes.
Sir, my name is Atik.
Atik, yes.
Sir, we are having a shortage now, sir. Does it affect jobs?
What?
Chip shortage.
Chip shortage, no, doesn't affect to your job. What is the meaning of chip shortage? Means there is no chips are running here.
Basically processors, sir, like semiconductors.
No. It will not. See, basically, you know, right? So just now the Micron company is having the plant in Ahmedabad. You know, almost it is 2,000 acres. So,
Oh,
so the next. So what I'm saying is very serious. The coming years, the India is the most fabrication plant. Actually, now even Apple, okay, even Apple also having the fabrication, that means manufacturing plant in China. Apple also. In America, they don't have. America is a marketing company. It's like America is a marketer. Okay, what it will be, what we can say. So America is leading, right? So, but America is Apple company. America is having Apple company, but they don't have a manufacturer. They kept the plant in the China. So who is the next manufacturer? India is a manufacturer. Then who will be the next future? India is the future for the plants, fabrication plants. Correct. So earlier China is there. Now the India will be in the future, definitely. So already Micron take the plant in Ahmedabad, Gujarat, I think Ahmedabad or something else. In Gujarat only they have taken plant 2,000 acres. They are manufacturing a fabrication. Then who will come here? Who will do the job here? Indian people only. That means the EC people only. They will take EC people only. Because every day for 10 years back, what you have? Only small Nokia phones are there. Now what we have? Mobiles are there. Currently, what you are seeing, mobiles, folding mobiles you are seeing. Correct.
yes, sir.
Folding mobiles. And how it will be transparent. Now you are seeing transparent mobiles. Earlier, 2 years back also, you are seeing only back panel is plastic and aluminum something. Now what you are seeing? It's transparent. Correct. Transparent mobiles you are seeing. So who will do that? The EC people, the technology is like that only. The technology will be more R&D is going. R&D means research and development is going on electronics. What is the Moore's law says? Have you heard? Anybody heard Moore's law?
Yes, sir.
Every
Yes.
we have to double the chips, transistors.
Yes. Every year. So that means just think about 10 years back. We have only phones, small phones, China phones, trending China phones. Now what we have? Smartphones. Correct. After the next years, how it will be? Correct, na? So who will do the R&D? Who are the major role in that? You think C language people? No. Hardware description language, who are knows? They will only do that. Who will do the Chandrayaan? Okay. The scientist name will come in the Chandrayaan, But who are the behind engineers? You are the engineer. The EC engineers only do all these things. They will do. Okay.
Okay, sir. Thank you, sir.
Yes. So that's why in the starting session only I told you people. Okay. I'm a EC student. That's why I'm proud. Okay. So coming to the topic. So I don't want to drag this. I will just these are the applications: research, academics, defense, prototyping, start UPs, hypercore developers, wireless communications, 5G. You know, if you maybe my suggestion is, if you after the interview, you can ask them and which type of projects you are doing, like that you can ask them. If they are saying like we are doing some wireless applications, just go and take that company. They will give you 10,000 also. Don't feel okay. You can learn that wireless applications project. That's it. The next year, how it will be, you don't know. It will be very rapidly, your rapid salary will be there after 1 year. Think about project. Don't think about money. Money will come, definitely. But the projects will not come. When you learn the project, how it will be, then it is very good for you. Okay. So coming to the flow. Okay. FPGA design flow, how it will be, right? We have a functional specification. After that, HDL code, we need to write for the HDL code. And after that, we need to do the synthesis. Okay. After the HDL code, behavioral simulation is there. That means behavioral simulation is nothing but by using the test inputs, we need to verify the code. Just like a very normal scenario. What is the meaning of synthesis? Synthesis is nothing but a hardware description languages which converts to the gate level netlist. This is the meaning of synthesis. Gate level netlist means what it means. If you write AND gate, after the if you do the synthesis, what it will appear? AND gate will be appear here. After the synthesis, we have a steps to see after the synthesis. We have more steps to see that. When you enter into the tool, Vivato tool or Cortas tool. After that, place and route. You know the AND gate. Where you need to place that? How the route will be in the hardware. That you need to give, right? After that, what it is there? Timing analysis. You need to check the timing also, right? Timing is very important. The time is very important. Not a timing. Time is also very important. If you utilize the 4 years of time, then you will get the job immediately. If you lose the 4 years of time, then you will not get job immediately. It will take some time, definitely. For me to get the job, it is take 1 more year. My 2017 is passed out of my MTech. After 1 year, I got job. Like that. So I'm telling you, if you utilize more in your time, the studies time, okay, you will get job immediately. If you lose it, then it will take 1 more year. Okay. So these are all and after that, what will happen? Download and verify in circuit. What it means? If you generate the bit file, it will generate 1 bit file. If you write a Verilog code for 1 lakh lines, it will give just small file. It will be in KBs only, just KBs. You write a code in 1 lakh lines, it will give only 10 KBs of file. It will be, you can dump that file into the board. Then it will be, give the result. You need to see that also. You can see whatever it is. See how it is the basic FPGA architecture, how it will be. Basically, the FPGA is having the 5 resources. Okay, 5 resources. One is IO blocks, CLBs, configurable logic blocks, BRAMs, block RAMs, DSPs, digital signal processing units, and clocking blocks. These are very, very important. CLBs and clocking blocks, IO blocks, BRAMs, DSPs. These are the 5 resources in FPGA. It is how the applications will be, depends upon the device. For example, if I take an FPGA 7 series architecture, right? There I have 60,000 VRAMs are there. 1500 DSPs are there. So you see, do you see that? Yes, we can see that in the FPGA. If you download the Verila code, if you download the Vibra tool, there you can select one package. Okay, FPGA is having different packages. There you can see multiple things, multiple inputs and multiple wires. Okay, based upon your Verila coding. CLB is nothing but a here configurable logic block. What it means? Configurable logic block, right? The CLB is having the pair of slices. Each slice is having the lookup tables and flip-flops and registers and latches and carry chain. Okay. So these are the main resources for us. What it will do? If you write a flip-flop code, right? If you write a flip-flop code, it will take one flip-flop here. If you write it 32 bits of flip-flop code, 32 flip-flops it will take here. Here, the lookup table, how many inputs you are having in the lookup table? 6 inputs you are having. What is output? Only one. Maybe sometimes it will be true also. It will come based upon your logic. What it means? Basically, it will act as a muxer only, right?
Excuse
What
me,
is a
sir.
mux? Yes.
So one basic query.
Hmm.
So if you
Yes.
write a code on the FPGA, can be erasable?
Yeah, of course, definitely. So that is why FPGAs are very user FPGAs. What it means, right?
User
We can
friendly.
reprogram. We can reprogram in the FPGA, but in ASIC it is not possible. Okay, I will tell you one example for the ASIC and FPGA. FPGAs is like defense and military programming it is coming. For ASIC, it's like a mobile. For example, do you think what do you think in about mobile, right? First you think about RAM. After that, what you will think about processor. Okay, now what is the trending processor? 8th Snapdragon 8th generation, for example. Snapdragon 8th generation +2, right? +1 is over already. +2 is came now. You just check your mobiles also. When it is started, you know, 4 years back only it is started. You don't know that. 4 years back only started. Now they are released now. So this is called ASIC. That means ASIC will take time to give a products generally. Correct. So now they are saying like OnePlus 11 Pro is coming now. Already 12 Pro is started. You don't know that. He will tell later, not now. So that means when you are designing one ASIC product, right, it will take 2 to 3 years of time. So much manpower is there to that. It's not that much easy ASIC to design development. But anyway, both are same only. But the thing is, ASIC is, it's like if you release the mobile, you can't take it back, right? Everybody is purchased. 1 crore people are purchased a mobile. That mobile is having so many issues. You think that they will give us money back? No, right? It done. That's it. They will do some more. What they will do technique. We'll release another updated software. Wait for some time. Definitely it will be resolved like that. They will tell. Correct? After 2 to 3 years, what will happen? The mobile was gone. Another new mobile came. That is called as ASIC. I'm telling you example because multi-million chips are used in the ASIC. They will be released instantly, not monthly. Okay, correct. When they will release mobile, just now they launched Nothing Phone 2 also launched, right? They will release almost millions of mobiles now. Next year they will release Nothing Phone 2, no, right? They will release another mobile. So that is what they have a plan to do that ASIC. So ASIC is can't erasable. We cannot do once the mobile is released. Nothing we can do, right? Okay, we'll wait for some time to get the software updates. That's it. We can. So FPGA is reconfigurable. How it is? For example, I'm using my military application here for 5 years in the same FPGA Spartan 6. I want some more updates. It is possible in Spartan 6. It is possible in any FPGA. It is possible to write the Verilog programming. You need to more extension to that. You can more extension to that, and we can write Verilog code. We can generate the bit file. You can take the bit file into the, put it into the board. That's it. It will do again whatever the operation you have done previously. It will override. It is arise, and it will come back. The new programming is coming. Okay, it is possible actually. So we are okay. Now we are in a CLBs, right? These are the things. Coming to how it will be DSP block. What is a DSP block? So many DSP blocks are there. Digital signal processing. These are all the DSP blocks, right? We have so many things in this DSP blocks. You have studied Fourier transform, right? For fast Fourier transform, JD transforms. These are all coming into this DSP block. You just go and write a Verilog code of jet transform. You will see. You definitely will get the structure of this. Okay. So you just look at here. Configure logic block is there, and next block is DSP block is there, and next is black arms is there. Okay, and next is okay. Here black arms are there, and coming here first here you can see IO blocks are also there. Okay, everyone is separated. Okay, side by side they are fixing. The FPGA is like that only, definitely. Okay, black arms. Basically, what is the meaning of black arms? Black arms is nothing but in this block arms we can write and we can read the data. Synchronously it is happen here. Synchronously mean what it means? Synchronous. Generally synchronous is nothing but a rising edge of the clock. We need to write the data. We need to take the data. We need to read the data. Okay, that is called as synchronous. What is asynchronous? When you are writing the data at the rising edge of the clock, when you're reading the data at the falling edge of the clock, that is called as asynchronous. So when you enter into the synchronous things, then you will get more very clear idea on this. I'm just giving you just normal sentence to you people to how to understand the things. What is a basic FPGA architecture? Hardcores. What it means hardcores? Generally, we have seen only resources. Coming to the hardcores, with the resources, we cannot do anything. When you have a hardcores, what it means hardcores? Memory, it will do only memory operations. You write the Verilog code, something. It will go into the memory here. It will go into the memory. When you write a Verilog code for the Ethernet related, it will go here, Ethernet related. It will not go anywhere because fixed functionality is there. You need to get the whatever you need to application, you need to get from there only. Okay. Okay, this is the compilation toolchain. How it will be in the FPGA. Level code. What is the meaning of level code here? Verilog language. Compilers we need to take. What is a compiler? Basically, compiler is nothing but a simulation. We need to check whether our system specification is just functionality is good or not. So that means it will be what we are thinking that it will come or not. That we need to know. That's why we are showing the simulation. Simulation is a process of we need to test the test bank. We need to test the suitable test vectors by suitable test vectors to the DUT. Okay, these are all definition, but the understanding capacity is we need to check the functionality of our design. After that, synthesize it, netlist, map and place route, constraint file we need to give, cycle level simulation, bit file. This is the tool chain. Okay. What is the synthesis? Basically, we have discussed, right? Transformation of a design from higher level abstraction to a lower level abstraction. But okay, but this basically here he written in a very high level language. I'm telling you very simple language. Hardware description languages converts into a gate level netlist. Whatever you write a code, that should be appear here. The code you have written, right? That should be hardware. Coming to the CLB structure. I told you, right? The CLB is having the pair of slices, 2 slices. See, like this, it will be appear in our J-Links FPGAs. 2 slices, the CLB having Pair of slices. Pair is nothing but a 2, right? 2 slices. How it will be? See, the slices is like it will be. Then switch matrix, slice, clocks. It is visible. It is very clearly visible inside the FPGA. Coming here, how it will be? How the architecture will be? 4 6 input lookup tables is having one CLB. Wide multiplexers are there. Wide multiplexers is nothing but it's like a multiplexer only, but it is connecting the big components to give one result of output. Generally, what is a multiplexer? 2 input lines, 1 selection line, 1 output line. Correct? 2 inputs and one selection line is also important. But the thing is, it will select whether you are taking 0 or 1 and to give the result. Flip-flops and latches are there. What is the meaning of flip-flop and what is the meaning of latches? Latches are level sensitive and flip-flops are edge sensitive. What is the meaning of edge? Edge is nothing but a rising edge or falling edge. We can call it as a trailing edge or leading edge. Correct? So these are all the scenarios interconnected with the FPGAs. So that means, so that's why I'm telling you, when you are learning digital design, right? There you have to concentrate on synchronous and asynchronous. What is the meaning of synchronous and asynchronous? Do you have any synchronous operations you have currently? You think that mobile is a synchronous operation? No. Mobile is an asynchronous operation. Correct? Why? Synchronous means it will never be possible in the rising edge of the clock or clocking edge of the clock. It's never possible to write the data and read the data. Every application is asynchronous only. We need to manipulate that to get the result. That's it. We are doing some logics we are applying to the asynchronous devices. Whatever it is, every application is asynchronous only. 100% that is. But we are manipulating that. We are modifying that. Okay. The lookup table having, this is also one of the different structure of a lookup table. See, actual structure of the lookup table, this is. Every lookup table is getting the result and it is going to one multiplexer. This is called as a wide multiplexers, and this multiplexer is coming and it is adding another multiplexer. Okay. Like this, it is there. It is connected like this. And the carry chain. What is the meaning of carry chain? Carry chain, it will do all the operations, addition and subtraction. Carry look ahead adder. You have seen, right? Okay.
Sir,
Yes,
hello.
yes.
Sir, good evening, sir.
Good evening.
Sir,
What's your
I have
name?
Kiran Kumar, sir.
Yes, Kiran. Tell me, Kiran.
Sir, I have one doubt, sir. Can I ask?
Yes, yes, sure, definitely.
Sir, in FPGA, we have a DSP block now, sir.
Yes.
In the DSP block, we are implementing adder multiplier. By using adder multiplier, we are reducing the memory, sir.
Okay.
So we can reduce memory, sir, or anywhere else. Memory in the sense lookup table. We are reducing lookup table. Only,
No,
sir,
we are reducing not lookup tables. We are reducing flip-flops. Memory means, yes. What is the meaning of flip-flop generally? It is stores of a 1 bit of information, right? 32 bit of flip-flops are there. Then how many flip-flops it is required for 32 bit? 32 flip-flops. That's why we know the logic, how to implement a 32 bit. Or you need to get the 32 bit of result. You know the logic, how it will be. You don't need a 32 bit of flip-flops. You need small flip-flops only. Okay. Then how? By using the, yes.
So using, sir?
Yes, yes. We have some techniques, right?
So
generally, we have some left shift and the right shift. What is the meaning of left shift and right shift?
Sir, actually, I am the research scholar, sir. I am presently, I am doing memory reduction, sir, by using DSP block.
Okay.
So in the DSP block, I am using adder multiplier is my basic blocks. But in the basic blocks, I am using OBC technique and same as SDR technique. So from that technique, I am
SDR
reducing
technique. Okay, SDR means software data recovery, right?
yes, software defined radio, sir.
Okay. Oh, sorry. Yes, software defined radio. Okay.
Defined
Oh.
radio. I am reducing memory, sir. So
Okay.
how much memory we can reduce, sir? And one more question is, are any possibility there for some other power area, ADP, PDP like this?
Okay. So, but as per my analysis, adder and
sir.
multiplier you are doing, right? So the project. So for by
Sir,
using
sir.
the software defined radio,
Sir.
software defined radio technique. So definitely it will take only DSP operations only, because
Sir. Yes, sir.
we have
Yes,
so
sir.
many blocks in the DSP, basically in FPGA. Which FPGA you are using, sir? May I know?
Spartan FPGA.
Spartan FPGA by using SDR.
Yes, sir.
Maybe,
Sir,
sir. Because
actually, I am not aware of that one. I am simulating only.
yes, I understood. But anyway, you are simulating. Okay, you are simulating, but you are not. The memory is not reducing. That's what you are asking.
Memory reduction is there, sir, by using OBC technique. That is offset binary coding. I am reducing memory, sir.
Okay.
I am reducing memory. So my question is, any other techniques are there to reduce the memory, sir? My question is, any other techniques are there to reduce the memory?
So basically, any other techniques means need to research more. Then only I can try suggestion. Otherwise, I can't, because the function you are doing Scholar means that is a big project only. It's not a small project.
Sir, initially I am using adders only, adders and multipliers only.
Okay.
That is adder and multiplier. First technique is MAC technique. After that, DA technique, distributed arithmetic technique. Like that, I am moving, sir.
Yes, sir. So please, no. What I'm saying is, I can't. I can suggest you when I see clearly. Otherwise, I can't suggest you, because I can't. It's not possible to me to give a unnecessary suggestion, right?
Sir, can you give your mobile number or email ID, sir?
Yes, sure, sir. I can give you, sir, definitely.
Okay, sir. Thank you, sir.
Okay, fine. Thank you. Yes. Okay. Almost done, I think. We have anything? So we have discussed all the things. Okay, we left one in the FPGA. The slices we have read. Slices is having two types of slices: slice M and slice L. Slice L is nothing but a slice logic, and slice M is nothing but a slice memory. So slice L is nothing but a logic and arithmetic functions. It can do the slice. Okay, the slice is the combinational logic is having the two pair of slices, right? Each slice is having the 2/3 of applications and 1/3 of memory 1/3 of logical applications and 2/3 of memory applications are there. Okay, so it will be taken according to our applications. See, slice M is nothing but it can be used for a logic memory or SRL, shift register logic, has wide multiplexer and carry chain. If coming to the slice L, it will do logic and arithmetic only. Lookup table can only be used for logic and has wide multiplexers and carry chain. Both it will be taken. But the thing is, the slice, that means the lookup tables is having some memory, and the sum of the lookup tables is having the logic. So based upon you written the logic, it will be go there only. It will not enter into the memories. Okay. It will depends upon taking the logic. After that, we have a different types of block ROMs. We have discussed, right? Block ROMs. There we have a simple port, dual port, simple dual port, quad port. These are all the operations it will do automatically when you write it. If you want it, definitely it will do like this. If you want a 32-bit port in a single port into two operations, it will come like this. If you want it single one, 64 into 1, it will come. It will access like this. Okay, the single port RAM, BRAM, the single port, dual port BRAM, simple dual port RAM, BRAM. Okay, so he has given synchronous write and asynchronous read can be converted to synchronous read using the flip-flops available in the slice. Yes. See, here dual port means what it means? One read or write port plus one read only port. Simple dual port. Dual port means definitely it is having the two ports separately. Maybe it is having the separately two clocks or only one clock with the different types of enables, read operations, write operations. Okay. And what it is, the slice M is used as 32-bit shift register. Why 32-bit shift register? It is having the 6 input lookup table. 6 lookup table, how many it is having? 6 inputs. In that 6 inputs, 2 power 5. 5 inputs are act as a memories, shift registers, and one is act as a selection line. That is why it is called as a 32-bit shift register. Okay. We can do anything by using this slices. Okay. These are all the things we need to learn in the FPGA because these are very basic questions. These are all very basic topics. If you want to go more about FPGA, then you can join in the FPGA team. Then definitely you will get it. I'm a FPGA and I'm a proud to be EC student. I'm a FPGA guy. I'm doing FPGA RTL design engineer basically. Okay, if I do, they will give me to ASIC design. You can design. Yeah, of course, definitely design. The difference is only tools will be different. Okay, the flow of tools is different. So nothing is there. Definitely, I can do that. So that's why I'm telling you the basic is very important. When you enter into the technologies, you learn it. You learn it. How much you have a strength, you can learn it. Then you can see how the future will be. For example, I am telling you, I started my career with 3 lakhs per annum. I work with the 3 lakhs only. Now I'm getting 10 lakhs, almost nearly 12 lakhs I am reaching within span of 3 years, within span of 4+ years. Okay. So enormously you are also getting, if you are getting the best in the product based company, they will give you minimum 20 lakhs of package for a fresher. 20 lakhs for a EC people only. No one will get that. That's why I'm telling you, as an EC student, you can go through this technology only, then only you will get enormous future and enormous growth, enormous money. That depends upon your talent. If you enter into the FPGA engineer, they will not give you. Depends upon the talent only, they will give you. In India, the engineer almost 15 years he is getting in India 1 crore rupees here only as a RTL design engineer. He has experience 15 years. He's getting 1 crore rupee. You think that in India 1 crore rupee will get the salary? Maybe. Correct? Now he is getting actually 1 crore rupee. Okay, that's what I'm telling you. Okay. That's why I'm telling you. Just learn this, all the digital basics. It is your future like that. You can think, you can go it. That's my suggestion. Okay. Fine. Anybody having doubts, please ask me. Okay.
Thank you, sir, for suggesting our students regarding everything, the career opportunities and the salary package and how the career will be if they pursue in this VLSI domain. Students, did you have any doubts? Please try to solve your queries now itself. It's a really and wonderful opportunity for you all people to discuss with a real-time working person. Okay, he's currently in his industrial domain itself, so you can clarify all your doubts. sir, one of the student had posted a question like, what is the roadmap to join FPGA?
The roadmap FPGA means what I can say. Try to search a job in a by using Verilog. You can mention your in CV. Just you know the language of Verilog and VHDL. C language you know, but you are looking for a job in a R&D based companies like whatever it is, or otherwise we have one option. Try to join in one of the reputation institutes like VLSI institutes, like some of the institutes, Sandipani is there and Maven Silicon is there. You can go through, join there, then definitely will get the job in clearly VLSI domain. Or otherwise, you have another option. Somebody is working on that in some companies like we in the VLSI domain. You can ask them; they will also help you. If anything opportunity is there, they will give you a refer. Then you will get the job. Refer means they will take you some gate only, but you have to clear your interview runs. I am telling you only one and only one option. You learn digital design very good, okay? Then you will get the job. He will not ask any other questions if you clearly give the answers to the digital design. That I damn sure. If you are not giving proper answers to the digital, he will enter into the Verilog and he will enter into some of the basics. Protocols, what you have learned, protocols. Okay, what you have done. Serial communication protocols you have done. Like that, they will ask. What are the projects you have done related to the VLSI in your project, in the final year of your project? In final year, you have done some projects, you go on somewhere else, you can buy the project, right? And there you can put some year in college. Not like that. You can choose your project in career based. You can choose your project like a career based, like FPGA. Okay. So then only you will get it. Yes. Anyone? Veda IT also very good. Okay. You try to join in that, but Veda IT is having per year 2 times the exam will be there. Minimum 3 to 4 rounds of interview is there. Okay. You need to give the very best digital design concept. Then definitely will take one. I think my friends are joined. And also you have another institute is there, Central Government Institute, CDAC. Okay. Center for Development. This one is in Hyderabad also available there. I think Hyderabad also there. CDAC. CDAC also one of the famous institute. Somebody is okay, sir. How can I learn that language? Verilog language. You can go through YouTube. That's it. Go through YouTube. There is some NISO Academy is there. So many are there. Whatever you comfortable with that. Then you can go through. Or you don't want to go to YouTube, you go to the Udemy, okay, An Academy, right? Udemy. So there you can go, there you will learn it. Okay, that also I don't want. Then you have another option. The IIT people are giving you NPTEL videos in the YouTube. IIT people, okay, NPTEL videos. There you can go and search it for VLSI. You will get the videos. Somebody, Sneha is asking, in VLSI domain, which field is better, SOC verification or FPGA? So anything is fine. Okay. So when you enter into the FPGA, when you enter into this field, this technology, FPGA or ASIC, wherever you want, you can go through that field. Okay. Because VLSI domain is a very good domain. Whatever it is, you learned it, you can go through it. That's it. Front end is the basic one to get the job. After that, you want to go to the PD, then you can change it PD also. You want to go to the verification team or testing team, you can go to there also. Somebody is asking Kiran Kumar B, DSP block latency. I don't know. So this is a very basic question, but I can't answer to that question. DSP block latency means I don't know. Is there any chance to join in FPGA after diploma? Yeah, of course, definitely. But you need to clear your degree. Then only it is possible. Degree is very mandatory. That too ECE background. Diploma is completed recently, but you can't get the job, right? Definitely, it is a mandatory. What is the starting package in FPGA? Okay, 70. The starting package in FPGA, I joined 3 lakhs per annum. Okay, somebody also joined 2.5 lakhs per annum, but now they are getting 15 lakhs also within 3 years of 4 years of span. No one will get that much. Okay. My career is starting with the 3, and after that 10. Now I got some hikes and all. Now I'm getting 12, 13. If I going out now, definitely I will get at least 18 to 20 within span of 5 years. But there is hard work is there. Nothing they will not give you if you have got 5 years of experience. Okay, there is hard work is there. You know, my one of my friends are taking 20 lakhs, 25 lakhs now. They are also same. My friend, actually he's my friend. He got a job in product based company, and he got there. Now they are getting 24 lakhs with the same years. But I am doing in some other company, Capgemini. He is doing in Intel. That is the difference between service-based companies and product-based companies. If you are getting the job in product-based company, they will give you much package. You don't know how much it is. In service-based company, they will give as per their basis. Yes, next. Have anything? Please ask me in the chat. I will be stay for 5 minutes. Okay. Already it is done. Only it is 1 hour. Can you give your mobile number, Kiran Kumar? Please ping me in WhatsApp. Okay. Take my number.
Sir, I will share it, sir.
Yeah, sure, Nitya. Thank you. Thank you so much.
Okay.
Okay. Ping me in WhatsApp. Definitely I will be available. If I am free, then definitely I will call back. Otherwise, you can ping me in WhatsApp. Okay.
Anyone still have any queries?
Is there the boards, this FPGA development boards?
Yeah, so yes, sir, we have evaluation boards are there. So that evaluation boards, we will get it by almost low packages. That means we need to show the just like some operations. It will be available within 25,000. Small evaluation FPGA kits are there. You can take that. We can give a trials on that actually. But based upon the applications, we need to take that. We need to see that also. If you want applications, then only you can see that. I can Sravanti. She's asking like EC background, which field is better, embedded or VLSI? VLSI is the first preference. Second preference is embedded. Both are same. Okay, but the thing is VLSI is very, very good. There is no much difference on that. What is the starting package for VLSI and embedded systems? Based upon the company. I cannot decide. Based upon the company. I told you, right? The product-based companies will give you the freshers nearly 10 to 15 lakhs or 20 lakhs. Okay, based upon interview. Coming to the Wipro and Infosys, so they will give you only 3 lakhs or 5 lakhs like that. That's it. As a fresher, what you are getting in Wipro or Infosys, right? TCS, 4 lakhs or 5 lakhs, like that only will get. When you it is a product-based company, then it is different. The salary part is very different, very much different. Okay, fine. Thank you so much, guys. Thank you for so much. Wonderful opportunity for me. This okay.
Thank you,
So
sir. And actually, I want to convey the thanks to you, having very good patience in dealing with our students and also having a great session with us for spending
yes,
with your valuable time in discussion of the career opportunities for our students and guiding them in each and every part and solving
yes,
all their queries. It's
yes,
really a wonderful session, sir. I hope the most of the students had enjoyed. Is it students? Can anyone respond? I hope you had learned something new from your college studies, right? And it's a very good, very great opportunity for them to discuss with a working person.
Yeah, thank you. It is an informative session. We really enjoyed. I think they want to know more about internship and how the students can get into this. So, sure, sir. Thank you very much
yes.
for.
Thank you, Sandeep sir. Thank you so much.
Thank you.
And very special thanks to the Mari Lakshmana Reddy College HOD for organizing this program and also for coordinating person like Dr. Prasad sir and also co-coordinator Arlanandan sir for organizing a very great opportunity for the students in order to discussing the to choose a right path for the career. It's a really a wonderful session with you people and also with the experts and also discussing with our team skill desire. It's a really and wonderful and very good opportunity for us too.
Thank you so much, Nitya. Thank you.
Yeah. Thanks to you also, Madam. I am Dr. Arlananda, co-coordinator of this event from MLR Institute of Technology.
Yes, sir.
Yes,
So you have also organized in well manner, in timely start and a timely end, and also information is carried well. And I think in the recent days, I am seeing that more number of students are joined in this meeting.
Yes, sir.
Such many, 230, 35 up to they have joined, and almost all people all stayed till the end of the session. So
Yes.
hope they got what they expected, and we will be in the touch for getting off the internship and other guidance to our students in the domain of VLSI.
Yeah,
yes,
And
sir. Sure, sure.
once again, thanks to the subject expert, he's given excellent talk about this VLSI and what is the challenges, trends, opportunities, everything has shared in the span of time. So thank you,
yes.
sir, once again.
Yeah, thank you.
Thank
Welcome.
Thank you, sir. And students, please try to fill the feedback form. Your feedback is very important to us, okay? Please don't forget to fill that, okay? Just listening the session and winding up, it's not a matter, okay? You must fill your feedback so that we can improve in our next sessions what to be done and etc. Okay? I hope you people got my point. And once again, a very, very great thanks to all the people for organizing this very great session with you. Okay, sir, then thank you. Shall I end the session?
Yes, yes, sure.
Yes, ma'am.
Thank you. Thank you, everyone. Thank you for giving me the wonderful opportunity here. Thank you so much. Have
Thank
a
you,
nice
sir.
day. All the best for every final year and third year people also. All the best for everyone.
Yes, sir. Yeah, guest, sir, where you are from actually?
I'm from Bangalore, sir.
Okay, good, good. You have studied all where?
I'm studying in Andhra Pradesh only, sir.
Okay, which college, sir?
I'm from Sri Krishna University, sir. Anantapuram.
Okay, good, sir. Okay, thank you.
Yes, yes, yes. Thank you so much. Welcome.
Okay, sir. Thank
Nitya.
you. Yeah, okay,
Yes.
sir. Thank you. Then I'm winding the session.
Yes, yes. Thank you.
And a very
Welcome.
good evening for all.